Welcome to Section 4.1, Lesson 1. Here we will analyze and interpret data from a histogram. Now, a histogram is similar to a bar graph in that it uses rectangular bars or bins to display data, but the bars are touching because it displays continuous data. So let's look at the graphs below. Here we have a bar graph that we looked at previously, representing the number of people who likes different types of movies. Now, because they're divided into different categories, comedies, dramas, action movies, then the bins are separated. Now let's look at the histogram. On the bottom, we have various test scores. So here are all the students who score between 50 and 60%. Then next to that are all those who score between 60 and 70%. And 70 to 80, 80 to 90, and then 90 to 100. So because all the data values are connected, the bars are touching. Now, because data is grouped into intervals, we can't find exact values. So for example, in the histogram, we can't determine how many students scored 83%. We do know all of those who scored between 80 and 90, but we can tell how many scored 83%. We don't know any exact values. So that is one disadvantage of a histogram. Let's look at example 1. Use the histogram that we were just looking at to answer the following. How many students score between 50 and 60? So that's right here. We can just look across and see that that corresponds with 2 students. Now, how many scored 80% or higher? So that's all the students here and here. So between 80 and 90, there were 8. And between 90 and 100, there were 1. So 9 students scored 80% or higher. Now, how many students wrote the test? Well, to do that, we got to add together all the 5 different bins. Now we know between 50 and 60 there were 2 students. Between 60 and 70 there are 6 students. Between 70 and 80 there's 13. And we know the last 2 are 8 and 1. So altogether there were 30 students who wrote the test. Now, when constructing a histogram, you're going to first want to determine a bin width, so that there's between 5 and 10 bars. So let's go back and look at the previous example again for a second. Here they had a bin width of 10. The numbers range between 50 and 60, 60 to 70, 70 to 80. But if I had to choose a bin width of 50, then I had all the students between 0 and 50 in one bin, and all the students between 50 and 100 in another bin, well, all the students would be grouped together in the same bin. So it doesn't give me an idea of the various scores that people had if they were all grouped together. So you're going to want between 5 and 10 bars. Then you want to construct a frequency table, which is a tally of how many are in each bin. Then you're ready to create your histogram. You include a title, label the X and Y axes, and you choose a scale for the X and Y axes, and then you construct the bars. So let's do that now for example 2. The number of days of sunshine in Tahiti for each of the last 40 years is recorded below. Draw a histogram to represent this data. So to start, we need to determine the smallest and largest number to help us determine the bin width. Now the smallest number I see here is 220, and the largest number is 284. So I think having a bin width of 10 would be appropriate here. It would give us 7 or 8 different bars, so that's good. So we have 220 to 230, 230 to 240, 240 to 250, 250 to 260, 260 to 270, 270 to 280, and then lastly 280 to 290. So go through each number and put it in the appropriate bin. So 272, go here, 236, here, 251, 271, 277, 251, 260. Now, I see that right here is 260 and right here is 260. So where do we actually place 260? Well, 250 to 260 means all the numbers starting at 250, but less than 260. So 260 would actually go in this bin. So I'm going to make a note of that here. 250 to 260 includes all numbers starting at 250, but less than 260. So that means 260 would go in the 260 to 270 bin. Now 265 is here, 272, 270 would go here, 223, 281, 250 go in this bin, 282 is here, 267, 233, 248, 265 is here, 252, 279. So if you continue on going through each number, there should be 3 in total between 220 and 230. There should be 5 between 230 and 240. And there'll be 4. And there are 6 between 250 and 260. Then there's 7 here. It's a total of 10 between 270 and 280. And then 5 in the last bin. So now let's do our histogram. We already have the title and the scale and the axes labeled, so we can just go ahead and draw our bars. Now between 220 and 230, there were 3. This 230 is here in between 220 and 240. Then between 230 and 240 there were 5. So notice I have the bins touching. Then there are 4. Then between 250 and 260 there's 6. Of course you should use a ruler to keep it nice and straight. Then you should have 7. Then 10. And then 5. So this is a nice visual way to see where most of the data is grouped.